Now we know the starter works because it's the same one that we used on a junkyard 455, but it did sound a little bit strange, so we're going to go ahead and rebuild it anyway just for reliability. Now, if you don't know the condition of the starter when you get it, here's a good way to check. Clip your positive battery lead to the power supply post on the solenoid, then clamp a load tester on the battery cable, making sure the scale is set to read at least 200 amps DC. Secure the starter to the table because it will want to walk when you put power to it. Now we just need to bridge the power over to the starter post on the solenoid. When you do this with a screwdriver like I'm doing, just make sure that your contact points are between the two nuts. Do not touch the threads because the arc will mess them up. Now the highest draw I saw was just about 70 amps, and the free spinning was just over 50. Now that's well within manufacturer specs. Now, if you're looking for the numbers for your starter, you can either check online or just give your local builder a call. These numbers tell us that this starter doesn't really need a rebuild, but we're going to do it anyway, just so we can show you guys how easy it really is. The solenoid comes off first. I'm marking the end plate and housing so I know which way it goes on reassembly. I'm actually making an imprint instead of using a marker so I can clean it and not worry. Now I'm willing to bet there's a lot of guys out there that have been building cars for a lot of years and they don't really understand how a starter works. Now a solenoid is basically nothing more than an electromagnet. When you put power to it, it attracts the cylinder, which pulls on the forks, and the forks right on the collar right here on your drive, and that's what actually engages your drive gear. There's helical cut grooves in the main shaft that actually spins the gear so it engages into the ring gear more easily. Next, pull the cover and remove the armature from the housing. Drive gears get worn down over time, which is why the kit comes with a new one. To remove it, use a socket to drive the retaining ring back, remove the clip, then slide the gear off. After getting all the crud washed out, some 1000 grit sandpaper or emery cloth cleans up the shaft and contact surface for the brushes. A coating of lightweight oil will make sure there's no hiccups when the starter engages. Drop the new drive gear onto the shaft, then install the new retainer ring and clip. Perfect. We're also replacing the bushing on the inside of the backing plate. I'm using a slightly modified punch and hammer to get it out of the way. Always test fit it just to make sure that bushing didn't distort when you're putting it in. Looks like we're good. Next come the 4 brushes. Now GM starters use 2 different sizes and the kit comes with both. So match them up before swapping them out. Now check out how much these brushes here wear down over time. Pretty amazing. And now when replacing the armature, be gentle. There are plastic pieces inside the housing that can be easily broken, so don't strong arm it. A couple of soft bushings cushion the armature from the end plate. A few drops of oil and we can seal it back up, making sure to line up the marks I made earlier. Getting the forks and the nose cone back onto the collar and the drive gear can be a little tricky, but once it's lined up, it should all fall together. Looks like there's no binding, so the solenoid can go back on. The last step is to throw some power to it and make sure the sucker works. Right on, sounds good. Now a rebuild starter is probably going to draw a few more amps than a good used one, but that's only because the bushings haven't quite broken in yet. Now this whole rebuild ran about $20 in less than an hour's time to do it. It's a pretty good investment.